Welcome everyone to the second actually meetup in September, right? The second online JSHeroes Meetup in September. We have a very special guest from across the ocean this evening, which we want to thank very much for taking the time. For those of you who don't know her, Anjana is one of our old friends of JSHeroes. She was a speaker at the conference in 2018 and in 2019. And just as a little insight, her talks were usually among the top rated at each year's event. So you're in for a treat this evening, I'm pretty sure. I know that she's super passionate about JavaScript and about the language itself. So I'm pretty sure this, as always, this presentation will rock. So yeah, I don't think I have anything else to add. Whenever you are ready, you are free to take the stage.
Hi everybody. It's so nice to be here with you. I mean, we are as with each other as we possibly could be, right? So I was really sad this year, as I said on Twitter, to miss my annual trip to Cluj. I've been like regular for the last few years. Was planning to go back again this year, and then the world had other plans. So this is it's really nice to see y'all virtually, if not in person, and hope to be back in Cluj sometime in the foreseeable future. Fingers crossed we all get to go back to traveling and seeing each other. But yes, my name is Anjana Vakil. I am coming at you from San Francisco, California today. And some of you may know it's a turbulent time over here. So if I'm a little off, or if we're all a little off, I think that's just kind of par for the course these days. Yeah. But let's just all be really like was said in the introduction, you know, everybody is just here to like learn together and share their knowledge. That's all I'm intending to do today, is like show you a couple of the cool things I've learned about generators. And it's a weird time in the world, so let's all just like try to bring that compassion and that empathy to these kind of meetups. It's really nice to like see some of you and know that the rest of you are hanging out here, and we have a moment to think about JavaScript instead of the rest of the world. So I'm going to share my screen. Before I do that, I just want to say that I have a lot of motion in my slides today. So if anybody has motion sensitivities, and this might be problematic for, like, maybe you can send me a message privately in Zoom or what have you, and I can try to adjust. But just as a warning, there is like going to be animation and motion. So let me try to share my screen and you'll see what I'm talking about. Okay, now when I did this before, it crashed my entire computer. So let's hope that that doesn't happen right now. All right, so far so good as far as I can tell. We looking good? All right, great. So I want to talk to you today about generators in JavaScript. I am a JavaScript programmer, among other things, but actually my first language was Python, and Python also has generators. And so when generators came to JavaScript in ES 2015 and ES 6, I was actually really excited because I thought generators were really cool from my Python days. And so what I want to do today is just tell you a couple of cool things that I think are cool about generators. And all of this is going to be posted online. And I'm realizing actually right now that it's not accessible yet, but by the time this presentation is over, you will be able to find these slides at that URL underneath my name. And you can find me on Twitter at Anjana Vakil. So yeah, I am a developer advocate at a place called Observable HQ. We are based virtually in San Francisco, and we make interactive visual computing notebooks that run in the browser. And that's what I'm presenting to you today. So we're going to talk about that a little bit later, but that's me. And most importantly, I like to nerd out about weird programming things that I think are cool. And I think generators are super cool. And hopefully by the time we're done today, I will have convinced you of the same. But I also think that generators in JavaScript are like really underappreciated. I don't think they get the love that they deserve, which again is why I want to talk to you about this today. Because I think that, you know, generators have been around in JavaScript for 5 years now, and I'm not sure that most JavaScript devs like love them as much as I think we all should love them. So that's why I'm putting this talk together, and that's why we're talking about this today. And the thing is that generators, contrary to some popular beliefs, are actually like useful pragmatically for certain day-to-day things. And we're going to talk about a few use cases for them. But if you ask me, more importantly, they are really great learning tools. They're really great teachers. And I've been learning a lot about some like core computer science concepts. I don't have a background in computer science. I don't know about the rest of y'all, if anybody wants to share in chat. But I think a lot of us in the web community and the JavaScript community might have non-traditional backgrounds and might not have done like a full-length college degree in computer science. And so if you're like me, you're trying to kind of play catch up all the time and learn some of these fundamental concepts in CS. And I think generators are actually really great windows into a few tricky things in CS. So that's what I'm hoping we're gonna start to expand our minds with a little bit by the end of the talk today. And really at the at the end of the day, I don't know if anybody saw my lambda calculus talk from was it last year, 2 years ago? But kind of like the lambda calculus, I think that generators are one of these kind of mind-blowing concepts that they seem really simple on the surface, but once you get into the nitty-gritty of like what you can actually do with them, it kind of opens up all these rabbit holes, all these like wormholes into just like stuff that you should not be able to do with a tiny little generator function. So we'll see if we have time to talk about some of the ways you can blow your mind instead of your call stack. Anywho, all right. So, but first, the basics of generators. I'm not sure, and it's a little hard since I can't see all your faces and ask you all whether or not people have encountered generators before in JavaScript. So I'm just going to go over some really basic syntax. Okay, so a generator in JavaScript is a type of iterator. Well, what is an iterator? Well, an iterator is just something that has a method called next, which returns an object of the shape that it has a value property, which might have some value that you're using, or it might be undefined. And then it has a done property, which might be which is a Boolean, true or false. So I'm trying to get my highlighting here. So any iterator, and it doesn't have to be a generator. There are other types of iterators that you might encounter. When you call the next method on it, you expect to get something out that looks like this. And as long as the iterator is still running, it will be churning out values and telling you that it is not done. Done is false. And then eventually, maybe the iterator will at some point tell you, actually, no, you know what? On that last call of next, now I'm done. And it might pass you an undefined value of that. And from that point on, any additional calls you make to the next method on the iterator will continue to return this done true object. It's like the iterator is over, it is done, there's nothing more to get from it. So essentially, this next method is what we can use in JavaScript to pull values out of an iterator. Okay, now there are other types of iterators which we're not going to talk about, but generators are one way to like get an iterator. And the way that this works is we have a new keyword since ES6, function star, which defines a generator function. And this is a little bit of terminology, but like a generator function here, this is a really simple one. You can often recognize them. Well, you can recognize them by function star, and often by there's a yield keyword in there, which we're going to talk about a ton. The generator function, when you call it, returns a generator object, which JavaScript knows is a capital G generator. And that object is the iterator thing that you can call next on to get values out. So in this case, the yield keyword is essentially telling the caller, whoever's calling into this generator with next, when like it's putting out a value that is going to show up in the next call to next. So in this case, we're just yielding one time, we're yielding one value, hello world. So the first time I call next, that is the first thing I get. I get this value, hello world, and then done, false. And this object is just created for me magically because I have this generator, which I created with function star. And then since that's the end of the function, there's nothing else there. I have an implicit return basically. When I call next again, I'm going to get that done true. Okay, so hopefully everybody's with me so far. I can't see you all. So you're going to have to, thanks, Alex. Okay, so these are the basic mechanics of how we'd work with generators. Okay, so this, just to drill back into this syntax a little bit, when I call next, I can think of that as advancing a generator. And when I see yield in the body of the generator, that's when I'm going to pause, basically, and spit out that next value. So here I've got a little generator that I'm calling logerator that's just being very vocal about what it's doing. When I instantiate that generator object by calling logerator, I get this generator called logger. When I call next on that, that is going to advance the body of this generator function till the first yield. So when I call the first next, it's going to run from the beginning until that yield statement. So what I see in my log is I'm going to see running, and then the output of that yield is going to be this object with value paused. Cool? So at this point, the generator is basically paused right here, right on the first yield. When somebody calls next again on the generator, it's going to resume where it left off, and it's going to run whatever is next until the next yield, or in this case, until the return. So when I call next again, I'm going to see that running again logged out, and then the next value that I get is going to be this return value, which allows me to basically tell whoever's calling that the generator is done. And I can optionally return a value, although those aren't often used very much. But basically that return, and remember there's an implicit return if you don't have one, that return is what stops anything that's looking at this as an iterator. Okay, so hopefully we've got the mechanics of generators now down. It gets weirder, but let's take a moment to review how we could use these generators, or anything that's iterable in JavaScript. We can use in a for loop, or something like spread syntax, or a few other places where JavaScript knows to expect an iterable. And a generator is cool because it not only is it an iterator, but it is also iterable, because it's kind of giving us a succession of values. So here I have a little generator function that just yields 3 values, A, B, and C, one after the other. I can use that in a for loop like this. When I instantiate the generator, I get something iterable that I can pull each letter out of. So if I log those letters after converting them to uppercase, I'll see A, B, C. And I can also spread that generator object. And note those parentheses, I do need to instantiate the generator. I can't spread the generator function itself. I have to call it to make a generator object, and then I can iterate over that because it's iterable in using the spread syntax to pull out an array, or using a for loop. Okay, so generators are both iterators and iterable. And you might be thinking okay, but why would I need to create a generator to yield A and B and C instead of just making an array for the first place? Yes, well, okay, this is a contrived example. You probably wouldn't write a generator like this ABC's one, but there are some really cool things that generators can do that just a simple array, or sometimes even a non-generator iterator, can't really achieve. So let's take a look at some of the things that generators can do when it comes to this iteration. So another thing that came along with generators and iterators was the notion of implementing your own iterables. In JavaScript now, since ES6, you can implement any object that you create can become an iterable, meaning something that you can use in a for loop or in the spread operator or so on, if you implement this iterator, this symbol iterator method. And you can, the way this works, and you can see in this little tiny example that I've got here, is let's say I have some object. This one I'm going to call card deck. It has a couple of properties. It has a suits array and a court array that represent the different types of cards that might be in it. I can write a generator function. This is just an anonymous generator function star here, which gives me basically a generator that will spit out for each suit. It will spit out all of the cards from 2 to 10, and then all of the court cards, and it will yield each of those successively. Okay, so I'm kind of, I've got a generator that's generating all of the cards in a deck here. If I assign that to the symbol iterator property, which is like a special, the symbols in JavaScript are these, like this way of accessing this like very special property, which then JavaScript runtime like knows how to use in for loops and in the spread operator. So by assigning a generator function, and it doesn't have to be a generator function. It could also be some other kind of iterator, but generator functions are really convenient ways for writing these iterators. By assigning an iterator like that to symbol iterator, I get an iterable object that, again, I can use in for loops, I can use in the spread operator. And in this case, if I spread it out, if I spread out my card deck object, I get this deck of cards with all of the different card and suit and card number combos that I would need. So this is one useful application of generators, is like they're very handy for implementing iterable objects. If you have like a special type of collection that you're working with and you want to be able to use it in for loops, they're great for that. And if anybody saw my talk from, I think it was 2018, you might remember me talking about this, about how you can actually, something that's really cool with generators is you can write kind of recursive iterators. So for example, and I go into this in way more detail in my talk from a couple years ago, so you can check out that video on the JSHeroes YouTube channel. But here I've got a little function that's going to spit out nodes for a tree. So I'm give this function a value, and it's going to give me a node that I can use to make like a two-branched, a binary tree holding a bunch of different values. So the way that works is I've got a little object that represents my node. It has a value property. And it's also optionally going to have a left child property, which is itself a node. And it's optionally going to have a right child property, which is, again, another of the same type of node. So what I've got now is I've got a generator function that is essentially recursively doing a depth-first traversal of a tree made up of these nodes, where it's first going to yield the value of this node, and then it's going to recursively yield everything out from the left and right children using this yield star operator. What yield star does is you can think of it as kind of like a for loop combined with yield. It expects something iterable after it, and it's going to successively yield each value from that iterator, from that iterable one by one. So in this case, if the left child exists, it's going to be another iterable tree node, and I'm going to basically call into its iterator property method to recursively yield out all the values. So if I have a little function here, make tree, which is going to take in this type of tree and sort of set up a little tree with many different values, I can then use that tree in a for loop, and I don't have to write my own code to traverse that tree. So yeah, if that didn't make sense or was really fast, don't worry, because I have a whole other talk where about half the talk is dedicated to going into this in more detail. Suffice it to say, what I'm doing here is using a recursive pattern, a recursive paradigm for thinking about how I want to do this traversal, and I'm implementing it as a kind of recursive generator using this yield star. So that is another cool thing that an array can't do. Silly arrays. Generators are way superior. No, just kidding. But actually more cool, if you ask me, is that unlike arrays, generators can give me lazy evaluated sequences, which means I can even make them infinite. So here I've got a little generator called infinity and beyond that's basically going to give me all of the counting numbers, all the whole numbers. So it's starting at 1. And look at this scary thing where if you're like me as a JavaScript programmer, while true should strike fear into your heart. But the thing is, it's okay in generators because that yield pauses. And it's only going to advance when somebody explicitly pulls a value out. So this is lazily going to give me each successive number, one after another. What I don't want to do is like spread this into an array, for example. That would not go well. But what I can do is write another little generator. This one is called take, which if you've worked in like other functional programming languages, somebody mentioned closure earlier, stuff like that. Often you run into this utility of take, which it basically gives you the first n items from some kind of iterable sequence. And so I've implemented stolen this implementation from one of the references you'll see later. But basically, we're just basically going through the iterable lazily. That's important. And we're stopping when we've counted off the number of items that we need. So on each run of this for loop, I'm going to count down the number of items that I need. So if I ask for 3, let's say, I will first yield the first item, and then I'm going to take 2 more, and then I'm going to yield another item and take 1 more and yield another item. And then when n reaches 0, I'm going to return and jump out of this iterator, jump out of this generator, so that the for loop doesn't go on forever. Because that's something that's pretty cool, is I can actually use an infinite iterable here in my in this take function. So for example, I can pass in the generator created by infinity and beyond up here, and I can pass it to take and say, okay, give me the first 5. That's going to give me a generator, which then I can spread into an array, and I get this array 1, 2, 3, 4, 5. And this is live code, so I can show you that this works with bigger numbers, with smaller numbers. And so what we can do is basically use infinite sequences and work with them as if they were regular old iterables, thanks to generators. And I can also make some other like helpful, lazy iterable processors, like the map function. So we're used to using a map on arrays, right? But wouldn't it be cool if you could use map on any iterable out there at all in JavaScript? So you could implement a generator that takes in an iterable and some kind of map function, and lazily is going to go through each thing in that iterable and yield out whatever the result of calling the map function on that item is. So for example, I could use this to square everything in my taken array. Here, I'm going to call my map function on my taken sequence and map each thing to its square. So I'll get this, this array now of the squares of each of the numbers. And this is lazily evaluated. This is not computing those values until they're actually asked for. In this case, they're being asked for by the spread operator. But if I were using this in a for loop, let's say, I would only be getting the next value that I need as I go through each run of that for loop, instead of having to set it up all in advance and use up all of my memory possibly. So this is pretty cool if you ask me. We can do lazy evaluation. We can do infinite sequences. And we can actually work with them as if they were regular JavaScript iterables. Okay, so here is another weird thing that we can do with generators, which I would never have thought of had I not come to work at Observable. Okay, how about using generators to do animation? What? All right, so the cool thing about generators, like all iterators, is basically that whatever's calling into that next method is controlling when the next value pops out. So what if we kind of hooked that up to the browser's to the request animation frame loop, like where we can ask for something new to draw on every kind of render frame that the browser is pulling up here? Could we use that to actually animate things with a generator? So, okay, bear with me here. This is going to feel weird because it is weird. I've got a little HTML snippet. This is just some observable that makes it that inserts a little HTML snippet onto the page. So I've got a div. I've got something, an element with ID animate me here, and it says generators rock because that's true. They do. Now, what I've done here is I've got a little animate function. This is a regular function that is going to basically grab that animate element, and it takes in a generator function, and it's going to pass that element into that generator function to create a new generator that's like aware of that element. And then using this redraw function, it's basically on each animation frame going to ask for the next value from the generator, which, as we saw earlier, means that the generator function is going to run until it hits its next yield statement. And then we could say, that maybe some of these generators will be finite. So if at some point I get the done true value, if I get done true out of the next method, I'm just going to return and like stop this animation loop. But as long as I still have values coming through, I'm just going to keep running this redraw function on every animation frame. Okay, I know this feels weird, but are folks with me? I can't see you all. So I'm just hoping and praying that you're with me. Okay, so now why would I do this? Well, because now once I've got my animation logic set up, I can write animators that are basically just generator functions. So for example, here I've got a little animator that's called slide right. It takes in my element, and it's basically going to reposition the element to a certain X value using a transform. It's going to translate in the X dimension by a certain number of pixels. And what this is going to do is just go through from 0 to 200 or what have you. But I could also imagine this bouncing back and forth forever or using Y instead of X. It's going to increment that X value and then perform the transform and pause with that yield. So now, if the live demo gods are with me, if I pass this slide right generator function to animate, it should run my animation for me. Let's see. I'm going to run this and, there it goes. Look at it going. Bye, generators. No, it's just going to stop after a second. Yay. So this is super weird. And you might think like, I would never do this. That may be true, but the advantage of this, because you could also write this animation yourself, like using your own loop. But the advantage of this is I only had to write that loop once. And now I can write whatever animators I want as generators. I could do a slide left or a bounce back and forth, or I could change the opacity or do whatever I want just by writing a generator instead of having to like redo all that looping logic. And so the thing is, this notebook that you've been looking at with these like text animations, which were designed by my teammate Mike Bostock, this is actually running on generators. Observable, which again is this platform for doing visual computing in the browser in these interactive notebooks. You're looking at an observable notebook right now. An observable uses generators and the animation frame loop to basically automatically pull once an animation frame from any generators that you give it in a cell. And then observable is also reactive. So basically, whenever something updates, the rest of the notebook that uses it also updates. So what's going on here is I have this little HTML snippet, and don't worry about these the coloring and the shading and these lines and all that. There's some little, not that complex, but little functions that are like computing based on a certain timestamp, based on a certain time representation. They're computing how to shade this thing. So this depends on this T value, and T here depends on basically the current timestamp, which is a built-in observable called now, which is actually, so this is coming from Observable standard lib. You can find the code on GitHub. But this is just a really simple generator that is just a while true loop yielding date.now. So every time, basically on each animation frame, observable is pulling a new value, the new date.now, from this now generator. And it's automatically making that available. And then any other cell, in this case, this T, this is a cell that depends on now, is reactively updating to that new changed value of now, which observable just pulled out of the generator. I should say the observable runtime just pulled out of the generator. And then if T updates, similarly, anything that depends on T, like this little HTML SVG element, is also going to reactively update. So that's how we're doing these animations right now. And we can nerd out about this for like ever and ever, because there are so many cool animations that folks have come up with just by writing really simple generators in their observable cells, because observable is basically doing that animation loop logic of figuring out that it needs to pull something new from every on every animation loop, animation frame. Yeah. Blah, blah, blah. So suffice it to say that, like, if this feels weird, it's actually, try it out in Observable. Try writing animators with just like a little yield statement. It's very fun. It makes life very easy when you don't have to handle all that animation logic. Okay. I'm just going to pause to take a sip here, and let's think about what this means in the higher level. What are all of these generators that we've been seeing? What are they doing? Well, they've been producing data, right? So like every time we call the next method, the generator produces a new value for us. And sometimes it could be also like doing some other side effects, like moving that HTML element. But in general, they're essentially producing data when we want it. So generators are really great for that. And that makes them really great for things like data, like, sequences and iteration, like we've seen. But the really mind-blowing thing about generators, and this is the part where I think it gets extra interesting, so I hope we're doing okay for time, is that they don't just produce data, they can also consume data. And this is something that I think we don't talk enough about with generators. So here is the weird thing about this yield statement, is that it is actually a two-way street. Yield doesn't just give us the opportunity to like pass out a value to whoever called the .next method. It actually also lets us pass in a value. I can pass some kind of input, some kind of value into my call to the .next method. And here's a super weird thing. That will become the value of wherever I have this yield statement, which means that I can use a yield statement in like an assignment, for example, or whatever else I want. This was something that took me a minute to wrap my head around. So like, let's think through this real carefully. I have this little listener generator function here. The first thing it's going to do before it pauses at any yield is it's just going to log out that it's listening. Then it enters this infinite loop, where the first thing it does in that infinite loop is the JavaScript's going to try to evaluate the right-hand side of this assignment, right? So it's going to see this yield and it's going to pause. And there's nothing after the yield. So I'm just going to be the values that I'm returning in my like value done. Done is going to be true. The value is just going to be undefined. We're not really using the value. When it hits that pause, that's when things get interesting. So, okay, the first time that I call next, what happens? Well, we saw this earlier. We start at the beginning of the function body and we advance until this next yield. So we're going to advance to right here, which means it's going to spit out listening. Now, the thing is, this first time that I call next, the generator hasn't really started running yet. So it doesn't have any way of capturing that input value. So this is an important thing that we're going to come back to. But basically, the first time you call next, the generator can't receive any input yet. So whatever input you pass to the first call of next is going to be ignored. It did not hear this first "are you there" that I'm asking it. But now it's running. It's in the middle of running and it's paused at this yield statement. Now, the next time that I call next, whatever input value is passed in, when the generator resumes at the yield, it's going to use that value as the value of this yield expression. So what I'm going to get is message equals "how about now?" And then it's going to continue running until the next yield. So it's going to run through this line. It's going to log "heard, how about now?" And then it's going to hit the loop again and pause again on the next yield, where it's ready to receive another input. So any successive calls to next are going to get heard by the generator. Okay, is this weird yet? Are we weirded out yet? All right, so takeaways are that you can pass in a value to next, and it will be used to replace whatever yield statement the generator is currently paused at. The first time that you call next, there is no yield statement that the generator is paused at. It hasn't started yet. So the first value gets ignored. So you often have to call next a first time, usually with nothing, to kind of prime the generator to receive input. But after that, you can pass things into it with next. Okay. Now, what this means is that you can be talking to a generator that is maintaining its own internal state and deciding what to do with the inputs that you're giving to it. So for example, I have a little bank account generator that represents a bank account. It starts off with a balance of 0. And first thing it's going to do, and as long as the balance is above 0, it's just going to yield out the balance. And in this case, I'm using both. I'm outputting a value with yield, and I'm pausing here to wait for the next input. So let's walk through what this is going to do. I instantiate my bank account generator. I call next the first time, no input because it can't receive any input on that first next call, as we said. And I get out the current balance, which is 0, because I just started, I haven't made any deposits yet. And the information that we are not done, the generator is still running, my bank account is still open. Now, let's say I call next with 50. We are paused right here. So 50 gets passed in essentially as the value of this yield expression. It gets added to my balance here. And then hitting the while loop again, it gets the new balance, the updated balance gets yielded out. I've now done a loop of this tiny one-line while loop. So what I get out then is the updated balance, value 50. And as I continue going, I can keep passing in more quote unquote transactions to my bank account. Like maybe I withdraw 10 and then I get a balance of 40 and so on and so forth until if at some point the balance drops below 0, I've gone bankrupt, the bank account is closed. And in this case, so like if I try to overdraw my account, I asked for too much money, I get back this done true and a little, I'm just using this return value to message the fact that I'm bankrupt and I can't make any more transactions with my bank account. And so what we've got here kind of is like this little generator, this little 4-line function is remembering where it's at for as long as I want until I hit some kind of condition that makes it return, or if it's got a while true in there, forever. And it can use whatever inputs I give it to make decisions about, for example, advancing through a state machine. So because generators remember where they're at, they're paused. They're not like a function where every time you run it, it's kind of starting from scratch. When you call into a generator, it remembers exactly where it left off. So you can do a lot with that. Okay. The interesting thing about this is if we think about it, with this two-way yield statement, what it basically means is that the generator can give up execution control. It can, when it hits the yield, it says, I'm paused, and it gives control back to whoever called into the generator, whoever called that next method. And then when whoever that person is, or whatever that part of the program is, when it calls next again, the generator takes control back and resumes where it left off. So the generator, with this yield and with the idea that next resumes the generator, can basically give back control to the outside world, take it back later and pick up where it left off. And it can kind of pass that control back and forth. This means some really interesting things for control flow. So in fact, generators are like, we're a really important step on the road towards async, which now we're all possibly used to writing async functions with await. And in a world without await, we could actually do something really similar by combining generators and promises and essentially using the yield keyword as our sort of await. So here's a little generator called async-ish. And it's not an async generator. It's just we're not using async or await here. We're reverting to a time between ES6 and between ES7. what I've got here is a generator that's yielding promises. Promises delay is just, this is a little helper from Observable that just is going to resolve a promise with this value after this many milliseconds. So this is just going to give us a little delay on when this promise returns. Okay. If I write another little function, and this is the part that, this is the crucial kind of helper. If I write a run function that takes in some iterator, in this case, it's going to be the generator, but, and some value, it's going to pass that value into the iterator by calling next, which is going to run, in this case, our generator up until the next yield statement. And it's going to get out whatever the generator yields back as this next object. And if next is not done, then it's going to wait for the value. It's going to assume that that value is like a promise, and it's going to wait for it to resolve and then keep running with the result. So what this does is basically the first time I call run with this async-ish generator, and I'm going to do it in a second, but we're just going to think through it first. It's going to run until the first yield. So it's going to run this. It should tell me that it's working. Then it's going to stop at this yield. And it's going to hand control over what's happening back to this run function, which has just called into its next value. And then the run function is basically using the promise, is going to wait and keep control until the promise resolves. And then by running again and calling the next method, is going to pass control back to the async-ish generator, passing in whatever the value of that promise was as the value of the yield expression, which then the generator is going to pick up from there and keep running, and so on and so forth. Okay? So what we've got is something that basically looks really similar to async await. Now, let's see if this works. I'm going to open up my console here. I'm going to clear it out. 1 second. Okay. If this works as expected, then we should see when I run this async function, we should see a little time delayed run of the, apparently it looks synchronous code, but it's not in my async function. Okay. Ready? I'm going to run this. Fingers crossed. Okay. It's working. Oh, it's almost done. And then it got hello world. Did you see the delays? I don't know if you did, but it did. It worked. Let's try it again. There it goes. It's working again. Oh, and it's doing it slowly because it's waiting for a second between each of those promises. Okay. I maybe am a little too excited about this. And you might be saying, but why would I do this? We have async and we have await now. Yes, that is true. But understanding the things that we work with every day is a pretty good idea. So if you ask me, like playing around with these generators and promises, for me, this was like really helpful to understand how this, like how you could do that kind of that control flow of sort of like, okay, let's stop on this promise now. Let's pass control back to the promise and wait for it to figure itself out, and then pick up where we left off when the runtime tells me that this promise is done. So learning is the goal here. All right, I'm running out of time, but I want to really quickly mention what we have just discovered. It turns out that generators can be understood as a type of coroutine. Now, if you're like me, again, no background in computer science, coroutine is one of those super vague words that like I have a very vague non-understanding of. But basically the way that I am thinking of coroutines now that I've learned about them through generators is that they're routines, or they're chunks of a program that can share control with one another. They can kind of pass control back and forth to one another or to some other context. And that allows them to cooperate and to basically return the control over what's running on the current CPU or in the current thread or what have you back to something else while they're waiting for maybe input from somewhere else, for a promise to resolve, for the user to give some input, whatever it is. So this gives us a lot of opportunities for weird, cool things on the level of like systems, on the level of processes talking to each other. And essentially it allows for things like cooperative multitasking. So I know we're like 5 minutes until the end of the hour, but I want to show you really quickly, if we have time, some cool things we can do with this notion of generators as coroutines. Okay, I've just got right now, I'm switching out of Observable because as we saw, Observable automatically runs generators, and that's not going to be useful for, for us right now because we're not going to be able to see what's happening quickly enough. So I'm just in a, I've just got some code that I've written up, and I'm going to just like really quickly show you what's happening. What I'm trying to do here is create two generators that talk to each other, and they're going to talk to each other by telling a knock knock joke. Okay, knock knock, who's there? These jokes. All right. So what I've essentially got is I'm going to have two players, and I'm going to put them in a little object which keeps track of which players I have available in my game here that I'm playing. Now, I could try to have two generators directly call each other's next methods to try and like go back and forth like that. But the problem is JavaScript knows when a generator is currently running. And if one generator is running and it tries to pass control to another, and that other generator is also running and passes control back to the first one, you're going to hit an error that says that the generator is already executing, and so you can't call its next method again. So instead, what I'm doing, and this is also stolen from one of the references that I'll show you in a second, is I'm setting up a little queue. It's sort of like a message queue. And I've got a little function called send, which is going to take the name of a player who I want to receive a message and some message that I want them to receive, and it's going to push that onto the queue. And it's also just going to log out what messages are being sent. And so then I'm going to have a little run function, which is basically going to take things off of this queue. So as long as there's something in the queue, it's going to shift the first thing off. It's going to grab the name and the message, and then it's going to find the player with that name using my little players directory here and call its next method with the message. So essentially passing in that input, as we saw, to its next yield statement. So this is just this little bit of indirection is necessary to escape that that kind of like you can't call into a generator that you're already calling into error. Which I could show you if we had a little bit more time, but just trust me, there's an error there. So what I've got now is I've got two little players, which are written as generator functions. I've got somebody who's knocking, who is going to send messages to the person who's going to be asking questions. So I've called the asker. So the knocker is going to start things off by saying knock, knock. And then it's going to wait for some input from the other person, which it's expecting to be a question that's who's there. And if the conversation goes as I expect it to, it's going to keep going with this knock knock joke format. And similarly, the asker, it's not going to say anything at first. It's just going to get ready to receive some kind of input but it's just going to hop straight to a yield. And then it's going to get some kind of some input. And if that input is not the phrase knock knock, it's going to stop. But if it's the phrase knock knock, it's going to keep going with the typical who's there, who, etc. flow that we know from knock knock jokes. Okay, I know this feels really weird, but it's a very silly, contrived example, but we're going to try to get these two things to talk to each other. So what I have to do is first set up my generators, my knocker and my asker, and put those in my players directory. And then remember, the first time I call next on any generator, it's not ready to receive input yet. So if I want these two generators to be coroutines that are talking to each other, I have to basically first call the next method a first time to get them ready for input. So I'm going to first get the asker ready, and then I'm going to send a useless message that's just like go into the knocker, which is going to start the conversation as soon as I hit run. So if I've done all of this right, when I hit run right now, we should see a really hilarious joke. Ready? Okay. It did it. So the first two messages are like from the system. They're telling everybody to get ready. And then we see the first message from the asker. The first message from the knocker. The asker responds, the knocker responds, the asker responds with the context that it got, and finally we get a hilarious joke. Okay, now you might be saying like, all right, but so what? You could have just console logged all of these things. But no, these two are really actually talking to each other. Like, let's say the asker doesn't feel like playing this game, and it's going to respond that it doesn't care. I think, oh yeah, I'm redefining things. So when I run this now, okay, everybody gets ready, and then the knocker goes knock knock, and the asker goes I don't care, and everything stops. Right? So like the rest of the conversation didn't happen. Similarly, like if we want to give a like a different response here, if I run this, the asker is actually receiving those responses, right? Like if the knocker gives me different information, the asker is going to respond to it appropriately. I didn't change anything about the asker code here. So these are like really actually talking to each other. And I don't know about you, but I think that that's pretty cool. What we've kind of got here is using these coroutines in this way with this like message queue. We've got like, we're sending messages back and forth, and we're allowing these two generators to like really send messages back and forth, almost as if like in any kind of message passing paradigm of programming. If you've heard me talk about like message-based object-oriented programming, or if you've heard about things like the actor model, like this is kind of in that direction. So generators and like these coroutine generators are a really great way to explore some of these like these interesting notions of computer science about like how elements of a program can talk to one another. So things like the actor model, things like systems programming, where you basically have the operating system and a bunch of little task processes, like sending messages back and forth to each other to decide what's going to happen when. This is like a huge window into all of that stuff. So yeah, I know we're pretty much like a couple minutes over time. Some folks have to go. If you have to run, no worries. So great seeing everybody. But if folks have a couple minutes, and Alex, I don't know if we have like a couple minutes, there's one other cool thing you can do with this weird actory, coroutine message passing thing. Okay, so you know how I love recursion. If you've seen any of my talks, you know I love recursion. And if you haven't, just take it from me. I love recursion. And I also love breaking recursion. So again, my talk from 2018, I talk about like the recursion limits and Stack Overflows. And if you've ever run into something called mutual recursion, you might have run into a Stack Overflow, or in some browsers it's called, like in Firefox, it's a too much recursion error. You might have run into an error where it's not just that I'm like recursing infinitely in a while loop or something, but I can have two functions that are calling into each other and creating a mutual recursive loop, which blows my stack. So for example, here I've got two really simple functions, ping and pong, and they are just basically calling each other, incrementing a number. So they're pinging back and forth. So starting with 0, it'll be like ping 0, ping 1, sorry, ping 0, pong 1, ping 2, pong 3, and so on and so forth, back and forth ad infinitum, until I hit the memory limit on my call stack, because I have too many frames piling up on my call stack, and I get a Stack Overflow error or a too much recursion error. And in this case, I was able, I did this beforehand just so I wouldn't slow my browser down right now, but I did this beforehand and got up to like around 30,000 ping pongs before hitting this error. Now, in other talks, I've talked about ways to escape this using like tail call optimization and tail recursion. But here's another way we can escape this. If I modify my little knock knock game a little bit, and I've just added a little bit of logging to this send function, but don't worry about that right now. I've replaced my knocker and asker with a ping and a pong generator players here. And in this case, I put a max on this because again, I'm afraid of crashing my browser because this whole presentation is in the browser. And yeah, I don't know what'll happen. But what I've got is I'm basically using the same send function, which again, I'll show you what I did in that logging in a moment. But using the same send and the same run functions, same architecture as before, I'm trying to recreate that mutual recursion example. So I've got a ping which is taking in an n and basically sending Pong the message of the next higher number. So it's incrementing n and then sending it. And then I've just put a max cap here just to, again, make sure I don't crash things until the end of the presentation. But so what I'm doing now is I'm setting up my ping and my pong. I'm sending them each the first message so that they get ready. Remember that first call to next is necessary so that they can receive input. And then I'm kicking things off the same way essentially as I did with my recursive functions with a call to ping of 0. So now if I run this, and this is going to stop after just a few, but I can see that this is working, similar to my knock knock joke. Yeah. Now, what I'm going to do is remove these max constraints. But to keep things sane, instead of console logging everything, because that'll make things super slow, I'm just going to console log the beginning and then the first, or like every time I hit 1,000, I'm just going to let me know that I'm still running. And then by the time we get to 1 million, I'm pretty confident that we have escaped the stack memory limits. So by the time we get to 1 million, I'm just going to stop with a return here. I'm going to stop sending messages and stop this running. Okay, so what I expect to happen now, and anything could happen, but when I comment out these lines, if I haven't made any horrible mistakes, which is a big if, when I run this code, we should see something really cool, which is this escaping this recursion limit. All right, so I'm going to run. It's going to tell me I have redefined things. I'm going to refresh. Okay. Everybody hold on to your butts. Here we go. Oh, okay. It's doing something. It's going. It made it. It made it up to 1 million and nothing crashed, right? Can you still hear me? See me? Okay. So what we've done is using this kind of actor-y, coroutine-y generator architecture, we've been able to escape the constraints of mutual recursion. Which again is just a hobby of mine. Escaping recursion limits is just something super fun. So yeah, I don't know, but I think that this is like super cool. And I didn't know that generators could do any of these cool things. So yeah, over time, thanks for bearing with me. But just to sum up real quick, generators are actually practically useful, where they're super useful for creating custom iterables or for working with sequences, which means, and also the fact that they can consume data as well as put it out means they're really great for data processing. You can actually hook up a bunch of generators to kind of as little data processing units. There's some in the resources I'll show you. There's some you can create like a programming language with a tokenizer and a parser and all this stuff. Like you can have tokenizers and do like natural language processing in generators. You can do all kinds of cool data processing. They can function as sort of state machines. Like we said, they maintain that internal state so you can decide like when to transition between states. And as we saw, I use them every day at Observable to power animation and reactivity because of the way Observable's runtime is set up to work with generators. So they are like practical things. I hear a lot of JavaScript programmers be like, why would I ever use a generator? Well, there you go. But also more cool, they're really great for learning computer science concepts. Like by playing with these generators, you can learn so much about how control flow works in systems. You can, as we saw, learn about coroutines, learn about how cooperative multitasking can work in systems, things like actor models, as we saw, and just some really low-level systems programming, like operating systems concepts, like traps and signals and things like that. You can explore all of that in JavaScript using generators. It's super cool. You can even learn stuff about functional programming, like the M word. There's a talk that I'll show you in a second that actually explains this. So I have some resources here, and I'm going to share these slides. The Miracle of Generators was this talk I saw, I don't know, 4 or 5 years ago by Bodil Stoke, who's this big functional programmer that talks about like what some of the stuff I've walked you through today, but in more detail. So check that out. Also really want to recommend, there is a Python programmer named David Beasley who puts out these awesome computer science courses on all kinds of stuff, like low level stuff, high level, all kinds of things. He has some really great courses on coroutines and generators and systems programming things you can do with them. It is all in Python, But Python generators and observable generators are really not that different. And so you can still learn a lot, even if you're not a Python programmer, from those courses. And then some other reference materials there as well that were super helpful to me. So please, like, keep learning about generators. Learning is an iterative process. It's an iteration pun. So like, don't stop playing with these and just like exploring what you can find out through them. I think that's the coolest thing about them, is that they're kind of like this window onto all of these like really hard but really interesting computer science concepts. So yeah, thank you so much. Mulțumesc. And I'm going to share the link to these slides. They'll be up on Observable. I forgot to publish before the talk, but you'll be able to find them there. You can reach me on Twitter at Anjana Vakil. And yeah, just want to give a huge shout out. Thank you so much, Alex, and the JS Heroes organizers for having me again, virtually this time. And thank you all so much for being here and for sticking with me through this very strange and hopefully interesting trip through the rabbit hole of generators. All right.
Thank you. Thank you so much. This was really great. Let's talk afterwards. We will book up the next 3 or 4 meetups, because with this level of entertainment, I'm sure we can we can do a series. It was great, really. Thank you so much
for being here, everybody. And yeah, I don't know if folks, I know we're over time, so if folks have to run, no worries. But if folks do have a couple of questions or things like that, I'm happy to hang out in the chat.
So do we have any questions? Everyone is really loving the presentation in the chat, but feel free to ask.
Would have been fun to see on stage, to get that energy to the public like you did in the previous JSHeroes conferences.
Well, hopefully I will get to see you all in Cluj some other time, if not next year, because 2021 is not looking amazing either, but hopefully 2022, maybe there's a vaccine or something. I don't know. We'll see. But eventually, I would love to be back with you all in person in Cluj one of these years.
Yeah, just a little insight from organizing the agenda for JSHeroes. The first rule is that Anjana's talk goes after lunch, when people need energy. Yeah, in case you missed her talks or you have never seen one of her talks, I think you have one of the most popular talks in tech, right? The functional programming one. It has hundreds of thousands of views.
It's the learning functional programming in JavaScript talk. Yeah, I don't know, folks found it accessible, which to me is really important for beginners to be able to relate to these kind of trickier computer science concepts like functional programming or whatever, because the reason it's important to me is because I am a perpetual beginner and I don't know what I'm talking about. So I love it when we all just get to like learn together and share the few tiny things we do know. So yeah, if you're curious about the basics of functional programming, I have a talk about it. And I think also my past JSHeroes talks have gone into some of the nitty gritty of some of the functional programming concepts that I find pretty fun and cool.
Yeah, I think they were shared, or one of the links is already shared here.
Yeah, so I just published my slides. Sorry that I didn't have those public beforehand, but you should now be able to find them at that URL that I just dropped in the chat, and hopefully we can like get it on the video or what have you, so folks can find it later too. But yeah, be careful with some of that code. Don't run some of the infinite code if you don't want your browser to crash.
I'm curious about something. You kind of took back the time. Like you reminded me of the period when, like, right after generators were announced and everybody was super hyped, and then it kind of dropped because I think async await was very fast to be standardized. Like Chrome, I think, implemented it on the fly. So then everybody started looking at async await and all these. There were libraries that supported this, but I remember a time when we were looking at libraries like Co to do asynchronous stuff.
Exactly.
Back then, like generators were like, oh my God, this is the best thing that's gonna happen to this language in in years. But since I guess since people switch to async await, they don't really find the use cases anymore. So I don't know. I guess what you presented today is a great example of things that could be still done with generators.
Yeah. So yeah, exactly. Now that we have await and async, like you wouldn't write that that async-ish kind of code with generators anymore. But I still think, again, it's useful like to think about how that would work to understand how like that control flow can be passed back and forth. But also the other stuff that we talked about, iterators, iterables, like I'm just constantly surprised like how generators, and maybe it's because like I came from a Python background where like people do use generators for iterables and all kinds of stuff. As sort of just like a tool, like another tool in the toolbox. And in JavaScript, I feel like, you know, people did get really excited about the implications for control flow and asynchronicity, but they kind of underappreciated the rest of the cool things that generators open up for us. So that's why I know it's like, it's not really a hot topic or anything anymore. But that's why I just feel like generators need some more love. So thank you for letting me nerd out about generators and why I love them so much.
And do you know if, like, for example, you mentioned at some point state machines and state machine libraries. Do you know if they in general are implemented on top of generators? I don't know.
I mean, that's a good question. I don't, like, there's a lot of ways that you could implement state machines, right? And you might have reasons for preferring like maybe a more full-fledged solution that's probably going to have like their own kind of object-like representations of states. I don't know a ton about state machine programming. I know they definitely want to, if anybody's curious about that, you definitely want to check out David Khorshid's work, the XState creator. But I'm not too sure about how those are implemented under the hood. But if you need like a tiny little state machine that's just like my little bank account example, I mean, that's contrived. But if you need something that's just kind of like, I don't know, remembering the number of clicks to something or what have you, and you're not working in like a whole web framework that already has its own notions of how it wants to manage state and how it wants to like think about that, which the thing is a lot of us day to day are, you could certainly use a generator to like implement a tiny little lightweight sort of state machine-y thing. But again, it's also useful for kind of understanding how those could work and understanding what the concept of like of having the notion of being in a state and transitioning between states like can feel like. So again, even if you would use some out of the box solution or some state management system that goes along with your framework or what have you to do that in real life day to day, like I still think that playing around with it a little bit is a useful way to kind of like internalize those notions and really like grok those concepts. For me anyway, I find it helpful.
Cool. Do we have any other questions maybe?
I don't know if I missed anything in the back scroll, but I don't see any questions from the chat. But yeah, hopefully. So this notebook that the slides are in, this is an observable notebook that now is public. So anybody you can read it, you can fork it, you can play with the code live in your browser without doing anything. You can just mess with it. But you can also leave comments on cells. So if you have a question about anything, feel free to also like leave a comment on that notebook, or hit me up on Twitter or all of the above, what have you.
Okay, great. Then if we don't have any other questions, I guess we can call it a day. I mean, for us, it's almost night. For
yeah.
you, it's a day. But
for me, I'm just getting started. I'm going to go to work right now.
Yeah.
But thank you so much for having me. Thanks everybody for sticking around. I know we went a little over time, but really great to see you all virtually or in the chat. And yeah, thank you again for having me. It's always such a joy to be at JS Heroes. Love this crowd. So hope to see you all again soon in person, sooner rather than later.
Likewise, thank you. And if anyone wants to hang around for small chat for 2, 3, 5 minutes, feel free. If not, have a great evening, day, wherever you are.
Day, middle of the night, morning, what have you. Thanks, everybody.
Bye.
Thank you very much.
Bye.
Anjana, when you said while true, I remember my first meetups at JSHeroes was one about generators. I don't know if you, Alex, remember, was Gabriel Limber presenting. And I saw there, I was at the beginning, I was like, while true, I was like, no, this is not possible. I was almost with the hand up, like, hey, it's an error there. And then it was a yield later, and he explained everything, and I was like, okay, now I got it. But it's
Yeah, well,
super strange,
no,
especially
you
when
can.
you're at the beginning.
It's like fear not. Like, for example, I showed you that while true that is actually running in my browser right now. The while true in the now generator for the observable standard library that's like constantly generating the current timestamp. It is just running. It's just running a while loop forever, forever. It's great. It's great because you can just pause every time, and you're not blocking anything. So yeah, I love while trues now. Used to strike fear into my heart.
Stop the recording, Daniel, by the way.
Okay, yeah, sorry.